All right, hey guys, we're in Helicopter Handbook, Chapter 4, page 6 of 18. We're going to be in the tandem rotor. Tandem rotor. Tandem rotors, sometimes referred as the dual rotor helicopters, have two large horizontal rotor assemblies, a twin rotor system instead of one main assembly, and a smaller tail rotor. Single rotor helicopters need an anti-torque system to neutralize the twisting momentum produced by the single larger rotor. Tandem rotor helicopters, however, use a counter-rotating rotors with each canceling out the other torque. Counter-rotating rotor blades will not collide with and destroy each other if they flex into the other rotor's pathways. This configuration also has the advantage of being able to hold more weight with shorter blades since there are two sets. Also, all the power from the engines can be used for lift, whereas a single rotor helicopter uses power to counter the torque. All right, so swash plate assembly. Swash plate assembly. The purpose of the swash plate is to convert stationary control inputs from the pilot into the rotating inputs, which can be connected to the rotor blades or control surfaces. It consists of two main parts, a stationary swash plate and the rotating swash plate. The stationary swash plate is mounted around the main rotor mass and connected to the cyclic and collective controls by a series of push rods. It is restrained from the rotating by an anti-drive link that can tilt in all directions and move vertically. The rotating swash plate is mounted to the stationary swash plate by means of a uniball sleeve. It is connected to the mast by the drive links and must rotate in constant relationship with the main rotor mast. Both swash plates tilt and slide up and down as one unit. The rotating swash plate is connected to the pitch horns by the pitch links. A freewheeling unit. Wait, let's get a picture of your swashes. Let's see. Okay, the freewheeling unit. Since lift in a helicopter is provided by rotating airfoils, these airfoils must be free to rotate if the engine fails. The freewheeling unit automatically disengages the engine from the main rotor when the engine revolutions per minute is less than main rotor RPM. This allows the main rotor and tail rotor to continue turning at normal in-flight speeds. The most common freewheeling unit assembly consists of one-way sprag clutch located between the engine and the main rotor transmission. This is usually in the upper pulley in the piston helicopter or mounted on the accessory gearbox in the turbine helicopter. When the engine is driving the rotor, inclined surfaces in the sprag clutch force rollers against an outer drum. This prevents the engine from exceeding transmission RPM. If the engine fails, the rollers move inward, allowing the outer drum to exceed the speed of the inner portion. The transmission can then exceed the speed of the engine. In this condition, engine speed is less than that of the drive system, and the helicopter is in the auto-rotative state. All right, sprag clutch. That guy is super important. And that would be that. Yeah, so that was your freewheeling unit. Anti-torque system. Yeah, we'll hold off there. All right, see you later. We're going to go on to page 7. That was page 6. Now we're going to go into anti-torque system. See ya.